We have this example. We are starting to use solver. We have this example of car models where Toyota Uganda, as a car manufacturing company, Toyota Uganda, a car selling company, has a product mix problem. It wants to mix red car models, blue car models, green car models, yellow car models, orange car models. Just imagine, it does not have the knowledge, little does it know that this kind of car model sells more. It doesn't know where to allocate the resources the more. Okay? So we have this kind of problem as Toyota Uganda. Okay? As we can see here, our model. So the product mix problem by Toyota Uganda, it is asking itself how many car models should be produced. Really, how many car models should be produced to maximize the profits given the raw materials? Yeah. So the unstructured problem that we have at hand, yeah, these are the car models that we are assuming at first, and we are assuming a profit per unit of this per each car model. But we are asking for sure what should be the actual car model per each kind of, what should be the actual amount of car models to be produced under each kind of car model given this profit, and yet we have to make sure that the parts on hand are available despite the fact that we need these components per each car model. We need to make sure that these components are included per each car model while utilizing only available resources. Okay? So in Excel, we start by determining the total, as in determining the objective function. Yeah? Remember, we say that we work around with 4 components. Those are the decision variables, the objective function, the constraints, and parameters. Okay? So when we shift our model to Excel, this is our model that we are going to formulate in Excel. It has the unstructured problem. The problem is not yet well formulated. We've not yet found a feasible solution to it. So what we do, we can move to our desktop. We can create a new folder. You could call it Winnie, whatever you want, but we normally save in our names and registration number. So it's such a Winnie, I prefer using my name. You open that folder, and within that folder you create an Excel file. So you can name it as solver sensitivity analysis tool. Okay, boom. So we can open our Excel sheet so that we can start formulating our model given the problem at hand of product mix by Toyota Uganda. So we can give our model a title before we can draw it. Okay, so you merge and center, then you give it a title, Toyota Uganda product mix problem model. Okay, model of prototype. Prototype. Okay, So we bring our model here, as we can see. You can bold in the title, you can choose to underline it, whatever you feel like doing. Okay, so here we have our model. And as we can see, we have car models, profit per unit, production level. Let me try to broaden this. Okay, so we have car models, we have profit per unit, we have production levels. So in solver, the first thing you should do is to start by determining the objective. By formulating the model. Then determine the objective function. Yeah, the objective function, as we said, is based on the decision variables, because after all, it is these amounts of cars that you want to produce that will determine your profit. Are we together? So we want to get the total profit. Remember, these are just profits per unit. Yeah. One unit, but remember we have 10 units under each, 10 units under each. So given the unstructured problem, let's first assume our total profit. So to get our total profit, we shall need to set this times this plus this times this plus this times this plus this times this plus this thing. But we don't do that in Excel, so we shall need to borrow the sum product function. So we place equals sum product, the M is missing here. Okay, here it is. Sum product. So you come here, you start by selecting the profit per unit, per 1 unit of cars, and the production level. You enter. So given our unstructured problem, at first we have a profit of $3,150. Okay, you can choose to change it to dollars. You can choose to change it to dollars with 0 decimal places. So dollars, they are normally US dollars. So you choose the English US dollars. You click OK. These are also dollars. These are dollars. So you reduce to 0 decimal places, then you select the US dollars. Then you click OK. Sorry. So this is the assumed, this is the profit as per the unstructured problem. So we want solver to create for us a structured, a well-formulated problem. Remember, a problem results into a solution. Without a problem, there is no solution. So we can call this as an unstructured solution or problem. The one that solver is going to help us get is the structured problem or solution. So we have the parts on hand constrained to 200. These are the components as per each car model. Since solver is a linear programming tool, red is aligned to these kinds of car components. Yeah, that's why they are saying car components required for each model. Okay, blue is aligned to these car components, green is aligned to these car components, yellow is aligned to these car components, orange is aligned to these car components. So as you're formulating a model, you make sure that the decision variables are well aligned to their particular aspects, to their relative to their aspects. So for me to determine the parts required, yes, these are what I have on hand, but you might find that what I need is even less than or beyond. So with the unstructured problem, we shall need to determine the parts required by having to multiply the units of red cars with its number of car components at hand, plus the units of blue cars times the number of car components at hand but of A, then the units of green cars times the parts of a given car components at hand. But we shall not do that. In Excel we have sum product still, so we shall say equals sum product sum product. So we shall need the production levels that given 10 units of each car model, 10 units of each car model. Each car model needs various parts, Each car model needs various parts so that it can be produced. So given 10 units of various car models multiplied by their various components needed, what are the parts required in total? It's what we are trying to determine. That's why we are using sum product by multiplying the units of car models. But you have to fix that figure because it's going to cater for each and every car component. You fix it by pressing F4, then comma. Wait, what am I saying? So you come and select this, you fix, comma, and then you select the parts, the parts of the car component A, So you select the parts of car component A and you close. What does it mean? That these are the parts required, These are the parts required to produce each car component these are the parts required to produce the 10 units of cars of all these car models for car component A. Okay? These are the parts required to produce 10 units of each car model for car component A. Then we can just autofill. You can see some are exceeding our bare maximum, some are below, some are more. So this is why we are saying this is an unstructured problem. But we want solver to get for us something that is structured, something that is more efficient, and it is aligning with our resources. So we formulated our model, we've set the objective function. So now we need solver to give us a solution, a feasible solution. This is now an infeasible solution because some things are exceeding our available resources. So what we do, we shall need to first copy this entire sheet so that we can keep the original work. Whatever I do, you keep saving. So what you do, you copy this work and you take it the next sheet. At times the sheet you could be requested to name it to original sheet, original solver sheet. Then as you go to sheet 2, you can call it copy or feasible solution. I'm just assuming a name. Okay, so you copy and paste here so that you can play around with the sheet. Okay, we've got our model now. So we want solver because our question was how many car models should be produced to maximize the profits given the raw materials. As per now, we are not maximizing our profits because some materials, some parts required are exceeding our constrained resources. Yeah. So, given the unity profit, yeah. Oh, sorry. Yeah. Given the unity profit and the car parts, the car parts at hand, what are the car parts required in the feasible solution? And what is the actual unity profit that is required? Because what we have here is just dummy data, just an unstructured problem. We are just assuming figures. But upon solver giving us a feasible solution, this profit per unit will change depending on that solution that it would have determined for us. Also, the units of production, the amount of car models will have to change. The parts required are going to change. That's why we are asked, what is the actual amounts of these? So let's go back to solver. So we go to the data tab. We have file tab, home, insert, draw, page layout, a review view. But here to find solver, you go to the data tab. What if analysis? You click the drop down. Sorry. Remember we said solver is a standalone tool. So we find solver under data tab and it is found at the corner here. In the corner here, that's where we find solver. If at all you do not have it, you go to file, more, options, you click add-ins, you double click add-ins. Upon double clicking add-ins, you don't tamper with anything here, but instead you cross over at the bottom here. There is manage. So you click on the drop down, you look for Excel add-ins, then you click go. Make sure here we have various checkboxes for analysis toolpack, VBA, Euro currency tool, solver add-in. So you uncheck all other checkboxes and you leave solver add-in checked. Then you click OK. Solver will be able to be reflected here. So you click solver. It is asking for the set objective. The set objective is to maximize the profit. So we select our value here for the profit to be maximized. Okay? By changing the variable cells are always the decision variables. Those variables that represent the amount, the quantities, the levels of production, they are always the decision variables and they are placed under the changing variable cells. So you select them. In this case, this is what represents the company's levels of production. So we select them. Then you start adding constraints. You add constraints. So constraint number 1, let's see what does it say. Constraint number 1. Constraint number 1. Sorry. Resource constraint number 1. Resource constraint number 1. The parts required should be, these parts required should be less than or equal to parts on hand. They shouldn't exceed the parts on hand. Yeah. So we come here and we be like, these parts required should be less than or equal to the parts on hand. Then you keep adding your constraints until when they are done. Constraint number 2 says from x1 to x5 should be integers. Remember, the levels of production are the ones representing x1 up to x5. So you come and say x1 to x5 should be integers. Then you add another constraint. They are saying x1 to x5 should be greater than or equal to 0. So you come back and you be like x1 to x5 should be greater than or equal to 0. You type it. Our constraints are done, so we can click OK. Upon clicking OK, we shall need to solve and get a summary of what solver has given us as a solution. After proving that everything is well formulated, you can go ahead and solve. If at all things are not well formulated, you can change, you can delete, you can reset. If at all you feel there is a constraint that you have eliminated, you can continue to add. Then under select a solving method, we have 3 solving methods. We normally select Georgian and linear, like by default, because it caters for all kinds of problems. Yeah, it is generalized. So you solve. Upon solving, you make sure that keep solver solution radio button is checked, plus the answer report. It must be highlighted blue before you go ahead to click OK. Don't save scenario, but rather click OK. Yeah, so we've been able to find a feasible solution. As we can see here, the levels of production have changed. In our original sheet, we had levels of production as 10 per each car model, but basing on what solver has given us, it says for you to mix well your products, you as Toyota Uganda, you don't need to produce red cars, you don't need to produce blue cars, you need to produce green, yellow, orange. Yeah, and it has given us number. Are we together? So the parts required, of course, they have changed. The total profit has changed. Here the question was saying this has to be total profit, not unity profit. Total profit. So how many car models should be produced to maximize? So this question, you come and answer it. You come and answer it by saying we need to produce these. Let me copy them. So you type and say we need to produce, we need not to produce red, is it red and yellow? Red and white, red and blue cars, red and blue car models, but rather 18 green car models, 29 yellow car models, but rather 18 green car models, 29 yellow car models, and what? And 60 orange car models, and 60 orange car models to maximize a profit of, you carry this figure here, $4098 of $4098. Yeah, solvers found us a feasible solution. All our constraints have been met. So they're asking how many car models should be produced to maximize profits given the raw materials. So this should be our answer here. Yeah. Then the car parts, like car parts requirements and total profit. So the total profit is this. Total profit is this. Then the car parts, you come here in the feasible solution that Excel has determined for us. You take these car parts required. Should be your answer. You come and say for A, because they have A, B, C, D. Okay, I think let's bring this here. So let's copy this, copy that. Oh, sorry. So we can copy this, we can move it here. Okay. So you bring these figures as well to align with the respective car components. Yeah. So what does that mean? It means we need 195 of A, 199 of B, 177 parts of car component D, like that. So you give a comment down here that we need you comment we need 195 car parts of car component A, 199 parts of car component B, and etc. Okay, like you complete the everything. So here the answer report that we got from solver. You may be required to write all the slack variables. At car component A, we had 200 resources, but it is only utilizing 195, so the slack is 5. Here we had 200, we utilized only 199, the slack is 1. So these are the slack variables, just in case you're being told to list them up. Okay, so this is our example number 1 for maximization. We can look at minimization as well. Thank you for being attentive.